We're going to second category. Find the flow rate. Flow rate means discharge. And again, even if I don't know, look at that, you have the diameter. So it's not category 3. And the elevation at point A and B is given. So it means that you have the losses between these two, which is 100. So the only thing that you don't have is discharge. Here we go. I will start from here. First of all, again, I will write energy equation one more time. And if I do that, I will end up this one. HA minus HB equal to HL. Do I have HA? Yes. Do I have HB? Yes. And it means that HL is 100 meter. Now I'm going to expand it. HL is equal to FL over D plus K of entrance plus K of exit multiplied by the velocities. The problem starts here, actually. Look at here. I don't have F. I do not have velocity. Why? Because I need discharge to find that. Velocity is Q over A. I don't have discharge, so I cannot find it. And there is no way to start solving that. Okay, you may think that I can find F, then velocity. But if you remember, F depends on Reynolds and relative roughness. Reynolds has velocity inside, so I cannot find F. And there is no way other than making one assumption. I will have an assumption here. Let's see. That's a very smart assumption because although you are using Moody chart, but you make like a way that gets out of Reynolds. Do you have anything came to your mind? I'm going to use Moody chart, but I'm going to avoid using Reynolds because Reynolds has velocity. Velocity needs discharge, and I don't want to get involved with that. What's your way? Anything came to your mind? Huh? Do you remember we had 3 types? It says that laminar turbulence, fully turbulence. Fully turbulence says that, okay, I'm independent of Reynolds. So I will assume my flow is completely turbulence. Or fully developed turbulence. In case that you do that, F just needs E over D. And since we calculated that, I'm not going to write it one more time because if you remember, we just find that. Now I need to back to Moody chart because I consider that it's complete turbulence and I need Moody charts. Let me see if I have it. 0.30, so I'm here and it's 5. 4 here, 6 here, so 5 is here. And since you don't have Reynolds, you just need to make a line here. This line this is 15, 16. So it seems that I can pick 17 here. So straight line, why? Because there is no Reynolds. F equal to 0.017. I will start solve that based on my assumption. I want to make sure that the assumption is not like very off. So I have F. I will start from here. HL equal to 100 equal to F L over D, K of entrance, K of exit, V square over 2G. 100 here. I have F right now. Actually, it's my assumption, so I'm not sure still. Over D plus K of entrance plus K of exit and V square over 2 multiplied by this guy. See if you can find velocity from this one and give me the number that you calculated. So for the midterm, probably you have one of these categories. We have a fourth category, which I'm going to cover it today probably, but that's a bit easier and like a bit different. Velocity. You cannot write any number that I wrote, just let me know so I will give you a hand. And again, category 2 and 3 are complicated. So you need to have the assumption. This one, the assumption is the highlighted one. To make it completely turbulent, to get rid of Reynolds. And for the third one, I will give you a hand how you can make it easier. What's your velocity? And in case that you find it, find the Reynolds as well. Velocity.
At 5.81 meters per second.
Correct. And if you find Reynolds, you will find something close to that probably. Check. Reynolds relative roughness. Or let me make it blue because in the previous one I made it blue. Reynolds relative roughness. Relative roughness, we previously calculated that. Reynolds is this guy. Guys, I'm not going to show you the Moody diagram again because if you remember, these are the exact number that we read the F. So F is this one. F old is equal to F new. So it means that you were right. In some cases, you need to make it twice or 3 times to get the new one. To make sure that your F is correct. But right now, it seems that with one step, I'm done because this one that I assume is the one that is the correct answer. But maybe you need to do it 2 steps, 3 steps to make sure that you are in a correct path. Did we solve the problem? No, it says that what's the discharge? But right now we know that the velocity that we had was correct. So you have the velocity Q equal VA. If I have one more paper, I will do it for you. So if you are done, I'm going to next page to make the Q, calculate the Q for you. So I just need to write continuity equation, which is this guy. Velocity was 5.81 multiplied by area, which is going to be 0.11 cubic meter per second or 400 milliliter, 411 liter per second.